formula of binomial to solve for to get the probability of for our trial, for our experiment. However, given that the trial is too large, it is actually quite large, right? We can use a table of cumulative discrete probability distribution, right, which look like this. Usually, if you try to Google, you can have several kind of table of cumulative, right? When actually we have several kind, right, of cumulative distribution table, right, depending on how they create it. The difference will be on how they accumulate the probability, right? By that I mean, right, if you try to refer to the general formula of binomial at the top of the table, you are going to see for this case it is written P capital X less than equal to K. What does it mean by this, right? It literally means that any probability value given in the table, right, will be the cumulative probability value, which means that the probability value that has been summed together, right, starting from 0 until the particular value that you are looking at. So basically, if you are looking at for this case x k2, right, k2 for n3, right, for the probability of 0.5, let's say, so you get 0.875. So 0.875 there, right, is not actually the probability for K2. It is actually the probability of K0 plus 1 plus 2 accumulate. That is what it means. So if you want to obtain the probability of 2 only, right, x equal to 2, or for this table they're putting k equal to 2, you'll need to subtract with the probability of 0 and 1. We are going to be discussing about that after this. This is just the idea. Now, so we also have the a formula to assist you in reading the cumulative probability distribution. However, I don't really suggest you to memorize this, because you can actually understand it rather than memorizing the way to calculate for a cumulative probability distribution table. Okay, so now let us try to look at example 2.7. Okay, so in example 2.7, it is a simple experiment of tossing a coin, right? Tossing a coin 3 times. Okay, so a coin is tossed 3 times, and one is to find the probability of getting exactly 2 heads. Up until this point, we have already learned on how to calculate probability, right? Generally, and also using binomial. So let's try to look at it one by one, try to solve it. Okay, so now let's try to forget about binomial first, right? We can try to solve it by using the way we have discussed in our previous videos, using just a probability distribution. So we know that, okay, when the coin is tossed 3 times, this will be the tree diagram. Okay, and look at the end of the tree diagram. You're going to see the sample space. We have 8 possible outcomes there. Okay, 8 possible outcomes, or 8 possible combinations. And let's go back to the question. They want us to find the probability of getting 2 heads. So look at the sample space. Okay, and let's create a probability distribution table like this. Okay, we have the probability of the number of heads. Okay, if you look at the sample space, there are combinations that contain 0 heads, which is T there, right? We have 0 head there. Tail, all tails. So which is equal to 1/8, which can be converted into 0.125. And how about 1? Do we have a situation that consists of 1 head? Yes. Right? 3 out of 8 consists of 1 head. So 3/8, which is also equal to 0.375. And then how about 2 heads? Is there any situation that the combination that consists of 2 heads? Yes, also 3. So 0.375 there. And then how about 3 heads? So we have only one combination that consists of 1 head. So we have 1/8 for that. So notice that if you sum all of the probability, you will get 1. Alright? So let's try to answer the question by using this table. Okay? What is the probability of getting exactly 2 heads? So just refer to the table for 2 heads and you'll see that the probability is 3/8 or 0.375. Okay, that is not by using binomial. Now let us try to use binomial. So to use binomial, of course, you need to make sure that the properties, right, are met. So basically there are fixed number of trials, so being tossed 3 times, and each trial consists 2 outcomes, check, and then we have the outcomes are independent from each other, check, and the probability of success, which is, for this case, they want to do heads, remain constant for each trial, which is 0.5, 0.2, 0.5. So basically we can use binomial. So let's try to use binomial to answer this question. So basically, to use binomial, you don't need to draw a table or sample space. So let us first let us do it properly. So we define the random variable first. What is the things of interest that we want to look at in this question? In this case, so our capital X will be the number of getting heads when tossing a coin. Alright, 3 times. So let us write down the expression. The expression will be capital X approaching to B. In the bracket, we have N and P. So the N is 3, which is tossing a coin 3 times. And the P is 0.5, which is the number of probability of success, which is probability of success in getting heads, 0.5. And then, now, let's calculate the probability. Alright, 2 heads. So the X is equal to 2. So this is how you write it now. Probability of X equal to 2. So we can use the formula. Okay, we can use the formula. So just substitute the N with 3, and then the X with 2, and P with 0.5, and Q also 0.5, because Q is 1 minus P, right? And calculate it, and you should get the same answer of 0.375, which is equal to 3/8. So that is how you use binomial. Right? You can also try to answer it by using the table. Okay? So this is how you use the table. If you look again, this is the previous table that I have shown you before. If you look at the table, right, for N3, right, 3 times, and for our case, the X is equal to 2, or K here equal to 2, the answer, and the probability of 0.5, you will get 0.875. It is not actually the same as our answer, which is 0.375. Why? Because as I said, in cumulative binomial probability table, the table is not showing the equal value. So 0.875 is not the probability for X equal to 2. It is a cumulative probability, which is the probability of X 0 plus 1 plus 2. hence you get 0.875. So how to actually get x equal to 2 by using this table? So just simply take the value of x less than equal to 2, right, which is consistent with the table that we have. So x less than equal to 2, which is 0.875, and then you should subtract other x that being accumulated in that value, which is we only want 2, we don't want 0 and 1. So we should subtract x less than equal to 2 with x less than equal to 1, which consists of 0 and 1 in there, right? So 0.875 minus with, equal to the table, you got 0.5 for x less than equal to 1. So you will get 0.375 as your answer. So it is quite tedious to use the cumulative table. However, it will be useful if it consists of a lot a case that has a higher end. Right? Just imagine that you want to find the probability of x less than 12, let's say. So if you want to use this formula, you will need to calculate it 12 times, because you need to substitute the formula for 12 different value of x each time. However, if you are using table, you can just simply subtract, you can just simply pick the value of 12, and you will get directly the answer that consists of the cumulative probability from 0 until 12. Right? So you can use either formula, table, or table, right, according to the situation, just to make it easy. Now let's look at the same example and try to find the measure of dispersion and measure of center tendency. So how to find the mean again? Right, so n times p. So n times p, 3 times 0.5, which is 1.5, and then the variance is npq, which is you times n times p times q, you get 0.75. So the standard deviation is the set of 0.75, you will get 0.87. Okay, so however, for the experiment of tossing a coin, right, like this, the mean number, right, for this case is 1.5. So basically, with the variance of 0.75, so it is not really possible, right, because that thing is actually discrete. So instead of 1.5, we are going to round it to 2, and variance 0.75 or standard deviation 0.87, we round it to 1. Okay, so that is a binomial distribution. Alright, so I'll see you in the next video. I may be discussing on other example of binomial. Okay.